Developer workflows have shifted towards autonomous agents. On average, these systems now execute 20 sequential actions before requiring a single line of human input. When an agent inevitably loops or breaks on step 14, the standard response is to go back to the start and rewrite the initial instruction. We tweak the phrasing, add capitalization, or ask it to act like a senior engineer, hoping the magic words will keep it on track. The data shows that's the wrong lever. A study of nearly 10,000 experiments found that context quality, not prompt phrasing, is the strongest predictor of success. Phrasing has a hard performance ceiling. Trying to fix these failures by dumping 200,000 tokens of uncurated files and documentation into the prompt window creates a financial problem. This chart shows exactly what happens to your API costs as agent workflows expand. At $5 per million input tokens, a 20-step session costs about $20. If you provide uncurated data, 40% of that window is filled with noise. You are paying an $8 tax on every session just to confuse the model. Fixing this requires a transition away from prompt engineering toward context engineering. Mastering how you architect the information you feed the model is the only way to stop compounding errors and plug the budget bleed in agentic workflows. Prompt engineering is about phrasing. It optimizes word choice, role framing, and instruction clarity for a single-turn interaction. But phrasing lacks staying power. By step 14 of a complex task, an agent often drops initial constraints and starts modifying files that were supposed to be read-only. Context engineering asks a different question. What does the model strictly need to know right now? It focuses on the total information environment, from memory systems to information ordering. This comparison matrix breaks down the shift in focus. Context engineering treats system prompts like production code, versioning them, testing them against model updates, and dynamically restricting the tools available to an agent based on its current phase of work. Over a long coding session, the results diverge. A prompt-engineered setup drifts into hallucinations as the context window fills. A context-engineered setup constantly curates what the agent sees, keeping it aligned with the goal. A perfectly phrased instruction placed inside a polluted, unorganized context window will still produce a bad result. Developers should spend less time A/B testing the wording of their questions and more time building out the information environment with the same rigor they apply to source code. One of the biggest reasons bloated contexts fail is a structural flaw in how large language models process data, known as the lost in the middle problem. This chart illustrates findings from Stanford NLP, mapping out how AI models systematically ignore facts buried in the center of large datasets. They retain the beginning and the end clearly, but gloss over the middle. If you naively append an entire codebase or massive API documentation to the end of a system prompt, you're dropping your most critical context straight into that central valley of degraded attention. The fix is a technique called information bookending. You place the system constraints at the very beginning, put supporting reference files in the middle, and restate the core task at the very end of the prompt. This physically shifts your critical instructions out of the degraded zone and directly into the transformer's peak attention zones. The sequence of your files and instructions is a structural engineering requirement. It is dictated by the physical limitations of the model's attention mechanism. Even with perfect ordering, a long agentic loop will eventually fill its context window to the absolute limit. When an agent carries its raw, uncompressed conversation history across 20 sequential decisions, it drags the cognitive overhead of every dead end into its next calculation. You end up paying API costs for outdated turns that no longer matter to the objective. This is what generates that $8 noise tax per session. This diagram shows progressive summarization, the primary mechanism to shrink that footprint. Instead of carrying every verbatim response, you periodically replace older exchanges with a structured summary of the decisions made so far. The operational rule is to trigger this compression exactly when the context window hits 60. The most powerful part of this file is the negative constraints. Explicitly listing prohibited coding patterns is highly effective because LLMs naturally skew toward common, widely used solutions that might violate your project's specific rules. But it requires maintenance. If you leave outdated conventions in that file, the agent will generate code based on rules you abandoned months ago. Documenting explicit prohibitions in persistent memory provides concrete boundaries that is far more reliable than hoping the AI infers what not to do from a single prompt. The evidence is clear. the quality of your context has overtaken the cleverness of your phrasing as the defining metric of AI success. This decision tree helps determine which layers of architecture you actually need, based on your specific workflow. If you only use AI occasionally for single-turn chats, standard prompt engineering is sufficient. You can safely ignore retrieval systems and compression overhead. But if deploying agents daily, your first step is establishing a baseline claude.md file for episodic memory. For team leads, implementing progressive summarization is a practical requirement to eliminate the compounding token tax across the entire team. Success has moved beyond conversational cleverness. The focus has shifted to building robust, efficient information architectures.